Would you like to learn to code by making video games? Well, this course is one of our all-time most popular courses, and it takes you through the Unity game engine and learning the C# programming language to turn you into a video game developer. Now, along the way, we make 5 really fun, interesting video game projects that are not only quirky and interesting to make, but also teach you the fundamentals of game development and game programming. We start off with a simple obstacle dodge game where you learn about player input and about obstacles, about collision, about the fundamentals of programming such as variables, if statements. You learn about collisions, triggers, prefabs, and a whole bunch of just getting familiar with Unity. Then we move on to a fun little physics-based game that we call Rocket Boost, where you'll learn about the Unity physics system. You'll be using force to push that rocket around. You'll be learning about fundamental things like namespaces and classes. You'll be using scene management to load levels, particles, lighting, and other useful game development tools. Then we move on to a project which is an old school rail shooter project that we call Galaxy Strike. In Galaxy Strike, you learn all about the Unity terrain and timeline tools and how you can use those in many different ways. We learn about arrays, for loops, code routines, and a bunch of other really important programming concepts. Then the next project we make is a procedural endless runner where you learn about obviously procedural generation for your world, learn about lists, pickups, animations, properties, post-processing, and a bunch of other really interesting principles. Then in the final project, we make a first-person shooter because everyone's got to make a first-person shooter. We call this project Sharpshooter. You learn about nav mesh agents, simple enemy AI, weapons switching. We'll be using Pro Builder for prototyping levels, be using raycasting for shooting, and a whole bunch of other first-person shooter game mechanics. Unity is still the premier game engine for indie game developers to make any sort of game that they would like. This is one of the best courses you're going to find to get in there and really sink your teeth into Unity, into programming and into game development. So I really hope to see you in the course, and I hope you join us, and I look forward to seeing the games that you create. Hello and welcome to the course. I'm Rick and this is Stephen. We'll be your instructors throughout this entire course. In this very first section, we're covering some of the housekeeping things. We're setting up Unity, we're installing Visual Studio Code, and we're going through a little bit of a play around with Unity. So if you're brand new to Unity, pay attention to this section. If you're not brand new, you can probably skip ahead or go quite quick and jump into our first game project, which is going to be Obstacle Dodge. I'll be teaching the first 2 sections of the course, Obstacle Dodge, where we're learning C#, we're playing around in Unity, and we're doing a very simple game that I think can be quite fun that you can torment your friends with. Then we're jumping into the next project, which is Rocket Boost. We're using physics, we're loading levels, we're using Scene Manager, and we're advancing our skills even further. Then I'm handing over to Stephen for the next 3 projects. What are we covering in your project, Stephen?
My first project that we're actually going to dive into is Galaxy Strike, which is really like your third project throughout this course. Galaxy Strike is a rail-based shooter emulating old school games like Star Fox 64. Your fourth project within this course is going to be Royal Run, a procedurally generated endless runner, which has got you bobbing and weaving in between a bunch of obstacles being flung towards you down a shaky sort of bridge. The fifth project that you're actually going to cover within this course is a first-person shooter called Sharpshooter. We'll be setting up a first-person controller and shooting enemies and managing different sorts of weapons that you can actually toggle in between. I'm super excited to cover all of these topics with you, but as you start your Unity game dev journey, it's extremely important that you really apply yourself throughout all the challenges that we're going to give you throughout this course. That's enough chat for now. Let's get started.
Hello and welcome. My name is Rick and we're making a project called Obstacle Dodge, which is a fun little avoid the obstacle style game which will allow you to learn the fundamentals of Unity and the fundamentals of C#. Now the game itself requires a player. The player will have input 4 to move up, down, left, right. We have a camera. We'll be implementing Cinemachine, which is cool. Obstacles to avoid. We'll have a bit of a score that goes up when you bump into things and the color will change when you bump into them. Projectiles will be flung at the player. Spinny things to avoid that are quite fun and interesting. interesting and fally things that are going to try to fall on the player from above. Now, the game design, we're not doing a lot of game design here, but it's good to know the core so we can get into the habit of what is our design, what's the player experience, what do we want the player to be feeling, thinking, what sort of environment do we want to create for them? Are we creating something where we want them to feel clever? We want them to feel that they should be careful? I don't think so. Nah, I think for this game, I'm going to make something that has the player feel more panicked and rushed. The core mechanic is pretty simple: move and also dodge obstacles. And our game loop is get from A to B. That's the game. Now, what do you do in this game? Well, you're getting from A to B. And in this project, we'll be learning a ton of fundamentals of programming. We'll be learning all about variables, methods, if statements, collisions, trigger volumes, player input, and a bunch more. We'll be learning some of the fundamentals of Unity, like how game objects work and how to interact with them, prefabs, cinemachine, tags, components, order of execution, and a whole bunch more. And to get us started, I have a quick, silly challenge for you. I want you to give your player a name. I'm going to be calling my player Dodgy the player, because we have to dodge around things, so that I give a little bit of personality to it. So have a think about that. And by the time we get to the next lecture, which is about to start, I want you to have thought about your game. Pause the video if you need to. Otherwise, I will see you in the next lecture where we get started making this really fun little project. And I'm looking forward to seeing what you create. Let's get started. In this lecture, we're talking about start and update, looking at the difference between those two. In this lecture, we're talking about start and update, looking at the difference between those two, and we're going to write just a really little bit of code to make our game object slowly move across the screen. Let's get started. I'm going to start with a challenge, and the challenge is to get the party started. I'd like you to create a new Unity project from Unity Hub using the Universal 3D pipeline as our rendering pipeline to add a ground plane into your project. That's a game object that will be a plane. And then to create your player using a cube as the game object. And you know what? Let's rename our player to something nifty. I'm going to call my player Dodgy, because the player is going to be dodging stuff. So there's your challenge. Pause the video, take that on. I'll see you back here when you're done. I'm in Unity Hub. I'm going to click on Projects, and then up in the top right, New Project. Make sure I've selected the right version of Unity, which I've got wrong a couple of times in a row that you haven't had to watch, but lots of cursing at the screen. Universal 3D. Universal is great for most prototype projects we're going to be working on. If you want something that's AAA and really shiny and beautiful looking, then high definition is what you would go for. But for now, we're just going to go with Universal 3D. I'll rename my project to Obstacle Dodge, because that's what I'm going to be calling it. And this is the correct location for me. I'm going to turn off Unity Cloud because I don't need it. Click Create Project. That'll take a while, so I'm going to pause the video and I will be back when it's ready. Okay, I'm back into Unity. It took about a minute for me to be up and running. You can see there's some information in our inspector and a Remove README Assets button. I'm going to click on that. I haven't clicked on it before. Proceed to get rid of the information there. Yeah, it just got rid of the stuff that we didn't need. That's cool. You can leave it or remove it, up to you. Now, first step of the challenge was to create a ground plane. So I'm right-clicking within the hierarchy, 3D Object, Plane, and I'm going to rename it to Ground while I'm here. I'm also going to click on R and just scale it up a little bit because I think I want it bigger. Next, we're putting a player. So right-click, 3D Object Cube. I'm going to rename this Dodgy the player, just so everyone who's watching knows that it is the player. And I'm going to squash Dodgy a little bit just to make Dodgy look kind of interesting, zip, like that. And we've got this global volume that's sitting right underneath my cube. I'm going to pop it all the way over there. It doesn't matter where it is at this stage. We can just get it out of the road. Just so you can see what's going on in my world here, I'm going to create a couple of materials for colors. So right click, create material. I'll call this dark color. Click on the base map. I'll go down to something that is dark-ish and drag it onto the ground, just so we've got a way of contrasting our player. And you can see it's really shiny over on the side. That doesn't help with you viewing at home, so I'm going to turn the smoothness all the way down so it's a nice matte color, just a solid color there. Right-click, create material, and we'll call this green, because this will be the Game Dev TV green or thereabouts. Actually, you know what? I'll get the exact color. I've gone and found the color hex value for my Game Dev TV green. So when I click on the color picker here, all the way down the bottom, the hexadecimal, I can paste it in. This is what I've got from elsewhere that I figured out what it was from Photoshop. and now it's the exact color that I want, just in case you were wondering how to do that. Now I can drag green over the top of my character here, my player. Next, I'm going to put a little bit of structure to my folders down the bottom here. So while clicked on the assets directory, I'll right click, create folder, and I'm going to call this materials, and then grab the dark and holding shift, click on green, so I grab both of them at the same time, drag it into the folder. I'll right click, create folder again, and I'll call this scripts. And that is where we're going to put our scripts, you guessed it. So double click on scripts to go inside that folder. And now I'm going to create a new script in this folder. So right click, create, and I will create a mono behavior script, which is the standard Unity starting point script. So I'll click on that. Before I click anywhere else, I'm going to rename this to mover. If you do happen to click anywhere else, you might get some problems. So make sure that you name it before you click anywhere else and accidentally bake in that placeholder name. And then the last step before I jump into playing around with this script and adding some code is I'm going to add the script to a game object. Why am I doing that? Well, a script or code that's sitting down here in our assets directory can't do anything because the game doesn't know about it yet. So I need to attach it to something in the world, to one of my game objects. And I can do that by dragging the mover script over my game object, or I can click on the game object, scroll all the way down the bottom, drag it into the empty area, or the last way I can click on add component and search for mover and then click on that to add the script. So add the script now in one of those three ways. And just to tidy things up a tiny bit, I'm going to close up the expandy box for box collider and for cube mesh and mesh renderer. We don't need to look inside those for now. So the next step is to double click on our mover script. And if Visual Studio Code or whatever you're using is all set up nicely, you should see our code in front of you. Now over on the left, got the Explorer, which is basically showing our project structure. And you can see I created a folder called scripts. And within that, I've got the mover script. I don't need to be looking at the Explorer for now. When you get bigger, busier projects, you do need to spend time in here, but I'll just click on the Explorer button. So it's all just code that's on my screen. So if this is the first time you're looking at code or the first time you're looking at Unity C# code, you might be looking at it saying, what's going on here? What does everything mean? We get some stuff that's already been put in there for us that gives us a helping hand. I'm not going to explain it all now. We'll talk about it throughout this project. We'll talk about what namespaces are and what using means. We'll talk about classes. We'll talk about public versus private. We'll also talk about what mono behavior is. And we'll be talking a lot about methods or functions. You can use those two words somewhat interchangeably. Basically, things that make things happen. So we've got start and update in this starting script that Unity has created for us. Now, what do we need to know about start at this point? What we need to know is that when our script or our code comes to life, and what I mean by that is when we click play, our play button to say, start the game, Dodgy the player is already in our scene. So at that moment, anything that is a component on Dodgy will be active. So the mover script will come to life, so to speak, which means start will be called or start will happen at that point. And then any code we have between our curly braces will be executed. So let's go ahead and write some code in here now. Just follow along with me, and I promise you as we go throughout this project, this will make a lot more sense. I'm going to start by typing in transform with a small t dot translate with an uppercase T, and then open and close parentheses, and then semicolon. We're starting off with the word transform, which is referring to the component that's on this particular game object. What does that mean? Well, this code is on this game object, and this game object has a transform. Transforms where the position, rotation, and scale lives and where we can manipulate those things. And then we've typed dot, which is the dot operator, which is saying access all of the things that transform can do or has access to. So I'm just going to delete translate for a moment. And you can see when I type dot, our IntelliSense should show us what we can do. So what transform is able to do for us, or access, it can access all these different things: find, forward, get child, get component. And if we scroll all the way down, you can see that in our list just here is translate, which is a method that's been created by the clever folks at Unity that allow us to move things. There's already the logic to know what this means when we type translate. And then within our parentheses here, the open and close parentheses, that's where we put some additional information to say, well, what sort of movement are we doing? And how fast do you want to go? And where do you want to go? So that's what we put inside these. This is where we pass in arguments because translate has some parameters. Those words might not make a lot of sense just yet, but we'll talk about that a bunch more. And then at the end, we need a semicolon, which is kind of like in regular talky language is a way of saying a period or a full stop, but in C# it wants a semicolon. Now, the reason translate has a squiggly line underneath it is it wants some arguments. It wants to know, okay, what's your X value, what's your Y value, and what's your Z or Z value? And there's squiggly lines underneath this because it's like, I don't know what an X is. Like, how far is an X? So I'm just using this as a representation to show that the X and the Y and the Z or the Z are these numbers just in here. So let's put some numbers in. I'm going to put in 1 for X. I'll put in 0 for Y and 0 for Z. I'll make sure that I've saved my script. So I'm going to go back into Unity. I'm going to grab my game window, which is where we see the game. We see what the camera is positioned and what the player is going to see. The camera is in a bit of a nonsense spot at the moment. It's not very close. Let's try something, just a little experiment. Click on main camera, F to focus on that. Scroll around a little bit if you need to be. What happens if we move it up? Oh, our game window changes because we've moved the position of the camera. What happens if we hit E and rotate it down a little bit? Oh, it rotates down towards the player. So I'm going to move in a little bit and down a little bit just to frame up my game object within the camera. So this is what the game's actually seeing. So now I'm ready to hit play and we'll see what happens over here. It goes boop and moves just one position to the right. If I click on the game object in my scene, you can see it's now got a value. It was at 0.07, I believe. Now it's at 1.07. So if I click stop, it will return back to the position it was before I clicked play. That's an important thing to know. And so let's jump back into our code now and have a look. That was in start, so it just happened once when we clicked play. If I grab all of this statement, highlight, Control X, and then paste this into update, we'll see something different. So what is update? As you can see, it's called once per frame. What's a frame? Well, a frame is every time our game calculates what should be happening in our world. And if we had 1 frame per second, the whole game would look like this. Blop, boop, boop, because the whole system is saying, I'm only doing one thing per second. If we have, say, 60 frames per second, it's going to go and calculate all these things over the course of 1 second, maybe 60 times or 100 times or 30 times, depending upon how many frames per second our system is capable of doing. And that means that things can move a lot more smoothly than just old-fashioned stop animation, so to speak. So I'm just going to give ourselves a little bit of space to see what happens here, because when I click play, it is going to go flying. Aha! Okay, I deliberately, well, not really. Okay, I made a mistake. I didn't save. So this is something good for us to learn early on. And I wasn't paying attention. It was in start. I hadn't saved. I'd moved it over to here. So the game didn't realize I'd made a change to my script. Now I've saved. Click on play. And now we're going to see way off into the distance. And why is it going so quickly? Well, we're moving 1 whole unit per frame. Let's make that smaller. Let's make it 0.01. So if we mouse over this, you can see cannot convert from double to float. Basically, Unity isn't quite sure what sort of number we've told it. Double, it's a type of number that allows us to have a lot of precision, and float is also a number that has decimal places that doesn't have as much precision, and it needs to know which of these ones do you want me to do. So we're going to be using floats pretty much always. There's not really any need for us to use doubles, and the way we denote that is put an F at the end of our number. So that's now a float. And Unity's like, okay, cool, I'm happy. We should be putting an F after the 0 and the 0, but the reason it didn't get mad at us when we did the 0 or the 1 is there was no confusion. It's like, okay, I can do what I need to do here, but we're going to put Fs after this now. It's good practice. Click on save, back over into Unity. Now, what do we expect to see? Well, I expect to see it move. Is it going to move quicker or slower? It's going to move slower when I click on play. It's moving at a nice slow pace. Okay, click the stop button. So that's all I wanted to cover in this lecture. It's just a very quick introduction to start and update, doing a little bit of code and making sure that it works in our game. Good work. I will see you in the next lecture. In this project, we're going to be building upon our fundamental programming knowledge and making a really fun project where we control a rocket ship. We can rotate left and right. We can boost and thrust. We're using gravity. We're using forces to propel the player through the air. We've got platforms. We can move them around. We've got obstacles to bump into. We're going to be triggering particles. We're going to be adding audio. There's going to be so many fantastic things we're doing in this project. Now, in terms of game design, the player experience I'm going for is precision and skillful. We've got a core mechanic, which is basically skillfully fly the spaceship and avoid the environmental hazards. The core game loop is get from A to B, so get from our starting platform to our landing platform to complete the level and then progress to the next level. And we've got a flow where if you're on your level 1 and you crash, you keep going on level 1, keep going on level 1. When you succeed and get to the end of level 1, landing on the platform, then you go to level 2 and so on. So that's the mechanism. And if we get all the way through to our very last level, we're going to be using our scene loading system with some interesting code in there so that if you get to the last level, we know that, and you go all the way back to the first level. So we'll be covering a bunch of things, classes and namespaces we'll be digging into, and through that process, we'll be talking about encapsulation, we'll be implementing input actions, switch statements, we'll be triggering audio, we'll be triggering particle effects, we'll be adding lights in Unity, we'll be using force and gravity and all those things to move our spaceship around, and a whole bunch more. And this really is one of my absolute favorite projects. It's really crisp and clean. It's fun. You get to dive into new principles in terms of programming. And you also get to flex your game design and level design muscles a little bit if that's what you're into. And as always, we love to see what you create. So when you get to the conclusion of this project, please do share some screenshots or some videos or some GIFs of what it is that you come up with. Let's get started with Rocket Boost.
Steven here, and welcome to the next section of the course, Galaxy Strike. Galaxy Strike is a rail-based precision shooter where we're not only actually having to be dodging and bobbing in between enemy waves using the timeline tool, we'll also be able to shoot the enemies with input-based precision. When it comes to the game design of Galaxy Strike, I'm going to be shooting for what's referred to as a tactical rail shooter. Not necessarily like an out-of-control bullet hell or anything along those lines, but a fun story-based tactical shooter where we actually have to shoot down enemy waves as they approach us, imitating old-school games like Star Fox and the like. The core mechanic I'd like to focus on is flying our player ship not only through the timeline that we can actually control, but giving the player its own custom and private movement inside of that rail. The core game loop I'll be shooting for is shooting down the enemies to reach the end. Now in our case, we'll only be creating one specific level, but don't let us stop you there. It's definitely the type of game that you could grow and expand on with multiple levels and create a full story-based tactical rail shooter of your own. Some, but not all, of the things that we'll be covering inside of this section are things like terrain tools. Those are the types of things that you can actually see that gives us that height-based map terrain that we were looking at, as well as all the things like the environment and the trees on that terrain. We'll be spending a lot of time inside the timeline. That's actually what gives us the control of not only our player itself, but also things like enemy waves and how and when we want to control them. We'll be touching on more audio techniques, as well as a different way to control input using what's referred to as an input action map. We'll need to learn about camera stacking, basically how to have multiple cameras in our scene at the same time. That's what actually allows us to show those portraits in the bottom right of my game view. We'll be covering things like vector arithmetic to get the direction that we're trying to point and shoot. We'll be talking about not only new particle system techniques, but also actually ways to interact with each individual particles using particle collision. We've learned the basics of prefabs, but there's a lot to learn with things like nested prefabs and prefab variants. When it comes to C#, we'll be covering a lot of different new techniques and software architecture, but to give you a little bit of a taste, we'll be learning actually how to clamp our player to different types of movement, how to slowly lerp it or move things over time, covering things like arrays, for loops, for each loops, and a lot more. There's a lot of customization and flexibility within this section, so you can actually tune and tweak things according to your needs. Whether it's creating your own fun and unique voice lines or just using the ones that Rick and I have actually provided for you within this section, I can't wait to see what you come up with. When you're ready to dive into the first lecture, I'll see you there.